Gas laws lecture number 5, ideal gas law. So in the ideal gas law, the equation for that is going to be pressure times volume equals the number of moles times RT. Okay, this law relates all 4 variables. So in previous laws, we were starting with an initial pressure and maybe solving for a final pressure. So in this law, we're not changing. We're not starting with an initial and solving for a final. Okay, we've got the pressure, the volume, the N, and the T. You might be saying, what's R? R is going to be our gas constant. Okay, this gas constant is 0.08206. And the units for that are liters per atmosphere divided by moles per Kelvin. Well, if our gas constant has these conditions, it's liters, atmospheres, moles, and Kelvin, we must have our pressure, our volume, our N and our T in these units. They must be in these. So let's say that we're going to take a gas. A gas has a volume. We'll say that initial volume that we start with is going to be 2 liters. Okay. And we'll say gas is a volume of 2 liters. We'll say the sample of gas is 4 grams of helium. Okay, we'll say we're going to keep the temperature is at 50 degrees. And we want to know what is the final pressure. Okay, so in this problem, we've got a volume, we've got a sample of gas, so we've got a quantity of something, so this is going to have to be in moles. We've got a temperature, and we're going to have a pressure. Okay, we want to know what is the final pressure, so just what is the pressure. Okay, so we're going to have a P, a V, an N, and a T. Okay, so our final pressure or our pressure of the sample, we don't know. But we do know the volume. The volume's at 2 liters. Okay, the sample is 4 grams, but this is in grams, so we have to convert this to moles. So to get this into moles, we're just going to divide by the mass on the periodic table. And this is going to give us 1 mole. This should have just been 2 sig figs. Okay, and our temperature was 50 degrees Celsius, so this is going to give us 323 Kelvin. Okay, so if we plug all this into our equation, we're going to keep our P because we don't know it, times our volume, equals our number of moles, which is 1 mole, times our gas constant. Our gas constant is 0.08206 liters per atmosphere divided by moles per Kelvin. Okay, and the last thing is to times it by our temperature, which converted into Kelvin is 323. Okay, so to get P by itself, we're going to divide by 2. Okay, our volume is now gone. I'm going to put this over here. Okay, so if we were to multiply everything on the top and then divide by 2 liters, we would get that our pressure is 13 atmospheres. Okay, so what this is saying is that if a gas has these conditions, its volume is 2 liters, its temperature is at 323 Kelvin or 50 degrees Celsius, and we have 1 mole of that sample, it will exert a pressure of 13 atmospheres. So in conclusion, the ideal gas law is the relationship between all 4 variables. We're not really changing, we're not starting with an initial and a final. We're just trying to find one of those 4 variables at certain conditions.